Remember?
Large size?
Yeah, it's a larger resistor physically. It's like 47 ohms. Okay, Newland, what?
It's a current sensing resistor?
Yeah, it's called a current sensing resistor, or referred to as that. So once there's excess amount of current, it's a big fat resistor. It can handle more current and dissipate more heat. At the same time, its voltage drop is going to increase, and therefore forward bias in Q2, which will conduct, and that's how the excess current is thrown away. Active protection circuit, R3, 4, 5, and Q2, yes?
Yes,
Sir. It's R3, 4, 5, and Q2. You better mark that right now. Those components create that active protection circuit. It's not R6, 7, 8, is it? No, it's R3, 4, 5, and Q2. That's part of that active protection circuit. Look at R1. What do you think that does? Look at it. Look how it's in the circuit.
That's base current.
Okay. Well, gee, it's connected to source, and it's also tied into the base of Q1 and the collector Q3. That passes current, doesn't it?
Yes.
Sir. Yes. Now R1 here, it provides base current and the collector current for Q3, doesn't it?
Yes, sir.
What about R2? What does it look like it does? Zener current and any current that's not being used by Q3, because resistors drop voltage and dissipate energy in the form of heat. Looks like a dual role there. Drop a voltage to provide a potential, and then dissipate energy in the form of heat, especially not being used by a circuit. It's called I squared R, or power loss. Yes. CR1. Hey, I got a zener in this circuit again. What does that do? Two jobs this time. Newland.
Controls the output voltage.
Not controls.
Set
Helps set the output voltage in conjunction with whatever R7 set to, since we got a variable resistor this time. And what else?
Reference voltage?
It acts as a reference voltage. Now, just because I'm not writing things down, you can hear the words coming out my mouth. So if you don't already have these notes, you better write them down now. Sometimes I got to take the spoon out your mouth a little bit. Can I write all over the smartboard? Sure I could, but I don't want to look like someone puked at it. Start writing all this stuff. What about R6, 7, and 8? What is, or are those components responsible for? Somebody else, Mr. Walsh. It's called the feedback network. Isn't R6, 7, and 8 make like a, if I take away the variable part of R7, it's like a string?
Yes, sir.
It's voltage feedback. Each one of these resistors will drop a certain amount of voltage, but here's the deal. The output voltage, in conjunction with VCR1's value, which will be in parallel with however much of R7 and all of R8, makes sense?
Yes, sir.
That'll help set the output voltage. So whenever the line and load change, that increase or decrease is felt back here, and R7 is tied to what of Q3? The base of Q3. So whatever potential is at the base of Q3, more or less, is going to determine how Q3 conducts, doesn't it?
Yes,
sir.
Q3 controls what? Q1! Q3 controls what Q1 does. What's Q3's alias? Yes, good job, Leach. Thank you. It's also called the error amplifier because it's acting as a comparator. Q3, by nature of how it's placed in the circuit, VCR1 or CR1, its voltage drop. Hey, it's pretty much, looks like it's tied to R2, the junction of R2 and Q3. There is a certain potential there. Bam. Once this transistor, Q3 that is, senses a change, either an increase or decrease of the base, that's going to cause that emitter base junction to either forward bias more or less, right?
Yes, sir.
Yes, sir.
Yeah, that's BEO3 stuff right there. And when we go through the regulation process, hey, conducts more or less, VCE is going to increase or decrease, and then that potential will be felt at the base of Q1, increase or decrease of base voltage will tell Q1 to conduct more or less, providing more or less current to the load, regulating the output nearly constant. So all these things I just said, does it make sense of how this circuit works and what it does?
Yes, sir.
Everything I just babbled on about.
Yes.
How many times have I talked about this to you now? This is the third time I've talked to you about this. In a nutshell, that circuit looks like there's a bit going on, but how I just described its function, does it make sense?
Yes, sir.
Yes, sir.
Okay. C1, what does it do?
Stability.
Same thing it does every night, just like all the other capacitors in these regulators. No. They go door to door and ring doorbells and run away. Load. What does that do? Just whatever I'm plugging in circuit, right?
Yes,
This
sir.
is gyro mouse. Hey, it's where my iPod, I plug in a USB port. Same. We use resistors to represent some type of device that I'm plugging into this power supply. Because if I take this away, isn't this point and this point in the circuit the rails? Isn't that like the output? Isn't that basically this thing right here?
Yes, sir.
It is. That's what it is. Rail, foreshadowed to B205. The bottom and the top, it's called the rail, foreshadow. So do we understand the basic operation, how this circuit works, and the functions of each component?
Yes, sir.
Yes, sir.
You need to know the aliases, the function of the components, all these things, and what else do we need to know? What's over yonder? We need to know the arrow analysis for this thing.